For the first time, rapid blight has been discovered on Poa annua in the state of Colorado. This discovery was made by Drs. Tony Koski and Ned Tisseret at Colorado State University in cooperation with Dr. Frank Wong at the University of California, Riverside. This discovery extends the geographic range for rapid blight. This video will discuss weather and soil chemical conditions at the time of the epidemic. Let's take a look at the weather conditions prior to the epidemic, and then we'll look at the soil, water, and chemical factors associated with the epidemic. These historical graphs from the Paste Turf website represent conditions just prior to the rapid blight epidemic in Colorado. The key factors I like to refer to are the temperature, normal high and low temperatures, dew point, and relative humidity. Note the higher than normal temperatures early in March and mid-March that favored development of POA. In addition, later in the month, note the lower than normal temperatures that would be expected to have resulted in some turf stress due to cold. Also note that later in the month, relative humidity was high during the period where heavy rainfall deposited more than a foot of snow on the greens that were later attacked by rapid blight. Although fluctuating warm and cold temperatures probably played a role in the epidemic, we suspect that soil salinity and sodium might also have been involved. Let's take a look at soil sodium conditions that are known to be associated with rapid blight. This graph illustrates the soil sodium levels at Santa Ana Country Club, where Dave Zardi is superintendent and where rapid blight was first discovered, compared to Friendly Hills Country Club, where David Michael is superintendent and rapid blight has never been diagnosed. Friendly Hills is about 20 miles from Santa Ana Country Club. The x-axis represents the quarters of the year, and the y-axis represents soil sodium in parts per million using Melic 3 extraction. In Southern California, where both of these courses are located, most of the water for turf growth during the second and third quarters of the year is delivered through irrigation. Irrigation water quality therefore has a great impact on soil chemistry. This graph of soil sodium levels in parts per million illustrates the accumulation of sodium at each location. The differences in rate of accumulation and initial sodium content of the soil is directly related to sodium content of the irrigation water. Remember, rapid blight has never been observed at Friendly Hills, where soil sodium levels never exceeds 110 parts per million. Santa Ana, on the other hand, always has sodium above levels of 110 parts per million and has a long history of rapid blight. Now let's take a look at the soil conditions in Colorado when the rapid blight epidemic took place.
This table lists soil chemical values from Colorado where we used Melic 3 extraction methods. These are labeled laboratory in this table. And we also looked at field electrical conductivity readings taken with the Spectrum Technologies Field Scout. These readings were taken in areas where rapid blight symptoms were present. To avoid rapid blight, it's important to maintain soil salinity below 2 decisiemens per meter, even though Poa annua can actually tolerate soil salinity up to 4 decisiemens per meter without serious stress. In addition, soil sodium levels above 110 parts per million are frequently associated with rapid blight, so we have to set the desired sodium level below 110 parts per million. We've also included a desired value for potassium of more than 110 parts per million. This is based on research conducted by Dr. Mary Olson at the University of Arizona and Dr. Bruce Martin at Clemson University. Their research suggests that increased potassium might suppress rapid blight. The results in this table suggest that salinity in the laboratory was not excessive, but that sodium levels were high. Contrary to the lab test results conducted on a 3-inch deep soil sample, where we saw that soil salinity is in the desired range, direct electrical conductivity testing in the field measures the thatch and soil surface salinity. The surface EC values in the field range between 3 and 4 decisiemens per meter. These values are high and consistent with conditions that are known to be conducive for rapid blight. So where did all of the sodium and salt come from? Let's look at the irrigation water chemistry from Colorado and compare it to water used at Santa Ana and Friendly Hills. Friendly Hills Country Club is a location where rapid blight has never been observed. And if you look at the water quality factors, all of them are within desired quality guidelines, with the exception of bicarbonate. Santa Ana Country Club, on the other hand, is a location where rapid blight is a constant problem. If you look at the water quality there, the desired levels are exceeded for bicarbonate, sodium parts per million, SAR, and residual carbonate, sodium carbonate desired values. In fact, the Santa Ana water has sodium parts per million that is about 4-fold higher than Friendly Hills, and the SAR is 10 times higher than Friendly Hills. Now let's take a look at the Colorado irrigation water values. The creek water used in Colorado is only used to irrigate greens during the winter months to keep the greens from drying out. This water exceeds all of the desired guidelines tremendously, except for residual sodium carbonate. This water is not used for irrigation during the summer. The irrigation wasn't deep because the soil was frozen a good portion of the time. The result was rapid accumulation of sodium on the surface of the greens.
The discovery of rapid blight in Colorado adds another chapter to the story of this unusual disease. The occurrence of rapid blight shortly after snowfall lowers and extends the temperature range for disease activity. This observation led us to reduce the rapid blight threat temperature to 45 degrees Fahrenheit or 7 degrees centigrade. Soil sodium and salinity guidelines continue to be valuable, and these two parameters should be monitored and managed for rapid blight prevention.